Part 1. Process involved in the palm oil industry. First, planting. Oil palm trees thrive in the humid tropics and require a large amount of sunlight and rainfall. They begin to bear fruit after 3 to 4 years and are harvested year-round once they mature. Second, harvesting. Workers use tools to cut down the fruit bunches, typically weighing between 10 to 40 kilograms. Third, transporting. The harvested fruit bunches are then transported to the mill for processing. Fourth, sterilizing. Fruit bunches are steam sterilized to loosen fruit from its bunch and to deactivate enzymes. Fifth, threshing. This process removes individual fruit from the bunch. Sixth, pressing. The flesh of the fruit contains the palm oil. The fruits are pressed to squeeze out the oil. Seventh, clarification. This step separates the oil from other parts like fruit particles, water, and impurities. Lastly, refining. The crude palm oil goes through a refining process to improve its quality before then being packaged and sold. Part 2. Wastewater characteristics generated by the palm oil industry. First, high organic content. Wastewater from the palm oil industry is uniquely characterized by its substantial organic matter. This doesn't just include the easily visible elements, like traces of residual oil, but also the often overlooked components, such as decaying plant debris from the fruit pulp and other parts of the palm. Over time, these organic constituents break down, leading to a range of environmental challenges if not treated properly. Second, suspended solids. The processing of palm oil isn't a clean break. Small, often microscopic, fragments from the fruit and other plant tissues linger in the wastewater. These suspended solids not only cloud the water, making it turbid, but also pose challenges for aquatic life if released untreated. They can settle on riverbeds, disturbing natural habitats and affecting the life cycles of many aquatic species. Lastly, nutrients. At a glance, nutrients like nitrogen and phosphorus might sound beneficial, reminiscent of fertilizers that boost plant growth. However, in excessive amounts, especially in water bodies, they can be detrimental. The wastewater from palm oil processing is notably rich in these nutrients, which, when introduced to lakes or rivers, can trigger a phenomenon known as eutrophication. This is an explosive growth of algae that, when decaying, depletes oxygen from water, jeopardizing aquatic life. Part 3. Effects if wastewater is not treated properly. First, eutrophication. As mentioned in the previous part, the high nutrient content, particularly nitrogen and phosphorus in the wastewater, can lead to eutrophication. This refers to the excessive growth of algae due to excessive nutrients in water bodies. As the algae die and decompose, they deplete the oxygen in the water, leading to a dead zone where most aquatic life cannot survive. This phenomenon can devastate entire aquatic ecosystems, leading to significant loss of biodiversity. Second, soil degradation. When wastewater seeps into the land, it can lead to soil degradation. The high organic content and chemicals can alter the soil structure and natural composition. Over time, the accumulation of harmful substances can contaminate crops and plants, possibly making them unsuitable for consumption. Lastly, groundwater contamination. If the untreated wastewater permeates deeper into the ground, it can contaminate the groundwater, a vital source of drinking water for many communities. Consuming such contaminated water can lead to a range of health issues, from minor ailments to severe, chronic conditions. Part 4. Wastewater treatment plant for the palm oil industries. There are multiple stages for wastewater treatment to ensure the maintenance of a clean and healthy environment surrounding the palm oil industries. First, primary treatment. Given the high content of suspended solids in palm oil wastewater, the primary treatment phase would focus on physical processes to remove these solids. This can be done using screens to filter out larger solids that might be present in the wastewater, and settle in tanks to allow the wastewater to sit in large tanks, facilitating the settling of heavier suspended solids at the bottom. Second, Secondary treatment. The primary treated water, now with reduced suspended solids, still contains a high amount of dissolved organic matter. Addressing this requires biological processes such as aerated lagoons to promote the growth of the microorganism that break down the organic content, or even activated sludge process, where these microorganisms form a sludge that can be periodically removed. Third, tertiary treatment. Given the high nutrient load and the potential for residual chemicals, a tertiary or advanced treatment phase is required in certain cases. This treatment focuses on using advanced membrane systems to filter out remaining fine particles, microorganisms, and certain chemicals, or even employ processes like denitrification and phosphorus precipitation to reduce the concentrations of nitrogen and phosphorus. Together, this process significantly improves the clarity or purity of the water, in addition to prevent eutrophication if the treated water is discharged into natural water bodies. Thank you for listening to this video. Any suggestions or comments can be directly sent to the producer.